Hi friends, I am Sairam Krishna and here are my friends Imran, Avinash and Mohan Murli Krishna are going to present our presentation on home automation using IoT. We are currently pursuing our third year BTech from VR Siddhartha Engineering College and going to the content. Here we will see about the introduction about the home automation and about the C programming, embedded system and the microcontrollers and Internet of Things and that we learned in the internship, and about the Blink platform and objectives of the project, requirements of the project and methodology, and finally the block diagram and the simulation part of the project. So first moving on to the introduction to the home automation. So first let us understand the about the automation. So in the present scenario, the automation industry plays a very major role in human day-to-day living. So here many of the industries are using the machinery instead of a human effects, so by which the time gets saved and also the production cost reduces and we can manufacture the goods easily. So in this way the automation has become very relevant in many sectors of the society like medical sector, food services, law enforcement, transportation system and many more. And coming to the home automation, so home automation is a system that allows users to control various applications of varying kinds and also makes controlling of home appliances easier and saves energy, so which we discussed before. And here we can increase comfort but also allows centralized control of heating, ventilation and also the air conditioning and also lighting. And home automation components are a smart device, a hub and connected applications. These are the requirements for the home automation. So moving on to these details, smart devices. So these smart devices are nothing but these are the devices which can be used in a home automation system, and they are the main part that implement the whole system commands. So examples of smart devices can be added like smart refrigerators, washing machines and light bulbs, etc. And coming to this smart hubs, so hub is nothing but a controlling center of the home automation system. So it is the piece that connects your individual devices and helps them to talk to the another like mobile apps. So coming to the mobile apps, here we use a Blink platform to control the devices in the simulation part that we'll see further. And coming to the advantages of the home automation, so these are the advantages like we can save the energy and also we can ensure the safety, and we can also access with a remote, that is like using mobile apps, and we can user can feel convenient and comfortable by using these. So and again we have learnt about the C programming, about its basic structure of this C programming. Here we have the basic structure of the C programming, and here the C we can use the C language at different levels like low level language as a low level language and medium level and a high level language. So we can see that the C language is a general simply a general purpose language. So we'll see in detail about this preprocessor and header files extension and the function body in further. So firstly header files. So a header file is nothing but a source file that have some extension with a .h extension. Here header files contains the function like prototypes or function declaration, and whereas the source code contains the constant. Coming to the main function, so main here it is a special function in a C programming language, and it defines the starting point of the program, and main here main is the first executed function. And also about the comments in the C, we use single line comments and a double line or multiple line comments. So we can use the comments like this for the comments in a C languages. And about the data types in the C, here are the two types of data types. One is fundamental types and one is derived types. And in fundamental types we have three types like integer, floats and characters. And in the derived types we have again four types of data structure data types, arrays, pointers, and structures. So coming to the variables, here variables are nothing but the names that are given to the storage areas that our programs can manipulate. So here we have declarations and some of the definitions and usages, and here we use the operators in the C programming like arithmetic, relational, logic, and many more. And now coming to the arrays, so arrays are nothing but we can simply say as the collection of the data of same data types. So here we have an example of an array. And coming to the pointers in a C language refer to the variables that hold the address of different variables of a similar data types. So here we have how the pointers works in a C language, and we have learnt about basic C programming and how to implement it. Here we got the output as an hello world. And now coming to the embedded system. So embedded system is nothing but a combination of hardware with the software which perform a specific tasks is known as embedded system. That means we are able to control the hardware components using the software in the embedded system. So here the embedded system can be independent system, that means it can be a part of the large system. So and the embedded system is a microcontroller or microprocessor based system. That means here we use microcontrollers and microprocessors for doing a specific task. So like for example, let us take a fire alarm. It will also run when there is a smoke. So based on the performance and functional requirements, it got divided into 4 types. So real-time embedded system, standalone, and networked and mobile embedded systems. So these are some of the applications of the embedded system like industrial robots and GPS receivers and digital cameras and micro ovens and many more like games. So these are the components of the embedded system. Here we have sensors that senses the inputs from the outside worlds. It may be analog sensors or the digital sensors, and it will transmit the data to the hardware unit. And here the hardware unit and the have a memory that have the coding part or the program. It will transmit the data from the program from the memory to hardware. And here we have the CPU for performing the ALU. So like arithmetic functions or many others like addition, subtraction, division and multiplication. And finally we have actuators. These help in actuating the relays or some other switches, so that we can see the output in an LED form or an LCD form or many other. So this all comes under the embedded system. So here we have totally the components of the embedded system. So these are some of the hardware components like power supply. So without power supply we cannot run any embedded system, right? So and we have the microcontroller which is a combination of microprocessor, memory, and also the some input and output ports all together in a single chip. And here we have memory, that is also if the memory in a microcontroller is not sufficient, we can add external memory to the microcontroller. And here we have the timers and counters. So here the timers are required for some time delays, and also for the communication port to transfer the data from microcontroller to the output side or to the input side, and finally in output and input ports. And from here my friend Mohan will continue.
Hi, this is Murali Krishna Reddy. I want to continue the presentation. Previously, my friend Sairam has completed the what is an embedded system. Coming to the Arduino board. Arduino board is also an embedded system used in this project. Arduino board consists of an Atmega 328 microcontroller. It consists of an input-output pins, digital pins, analog pins. It also provides access for 3.3 volts and 5 volts. It has V-in and ground pins. It also consists a crystal oscillator, voltage regulator, and a power button. USB port, also a reset button. Next we come to the microcontroller. The microcontroller that we used in the Arduino board is Atmega 328 microcontroller. There are many microcontroller series that we used in Arduino board is Atmega 328. A microcontroller is a compact integrated circuit designed to govern a specific operation in an embedded system. It consists of many components and peripherals. It includes a processor, it is also called a CPU, and a memory. It has both RAM and ROM. Next, it also consists of counters, timers, next analog to digital converters, and many other. Now let us look deep into each component. The main part of the microcontroller is a CPU, central processing unit. CPU is an analogous to processor in a computer, which is basically an ALU, that means arithmetical and logical unit, a control unit, a register array. This is combinedly called as a CPU. As the name indicates, it performs arithmetic and logical operations on the data received. Next, coming to the RAM and ROM, these are the memory units present in the microcontroller. RAM is an random access memory. It is an volatile memory. That means when the power is off, the memory is erased completely, and on the next time we power on the device, we can again store the data. RAM is used in data memory and ROM is used in program memory. The program and instructions that we want to perform is stored in ROM, and the data on which we want to perform the instructions are stored in RAM. Next, ROM is a non-volatile memory. That means it stores data permanently on it. And next, coming to the input-output ports. Microcontroller provides multiple general-purpose input-output ports, pins, which can be configured as input or output pins by writing a particular configuration registers. These pins can be read or write high or low states from its pins. Next, coming to the clock, a microcontroller requires a clock pulse to perform every function in it. Next, as to execute and driven by the sequential logics as explained above, clock source can be external like crystal oscillator or internal like RC oscillator. If we want to provide a clock source inside the microcontroller, it should be an RC oscillator. If we want to provide it externally, it should be a crystal oscillator. In the previous Arduino board, we used a crystal oscillator which is external to the microcontroller. Next, in addition to this, it also consists of many peripherals called UART, that means Universal Asynchronous Receiver and Transmitter. Next, Serial Peripheral Interface, SPI, and Inter-Integrated Circuit, I2C. These all are serial communications for serial communication, and it also consists of timers and counters. Next, it also have pulse width modulation modules, compare modules, capture modules, and analog to digital converters, and many other. Next, coming to be what we microcontroller used in the Arduino board is Atmega 328 now. So let us now find what are the features of this Atmega 328. Coming to, it consists of a 8-bit AVR type CPU. This is a type of the CPU we used in Atmega 328. And next, the CPU speed is maximum of 20 MHz. And next, coming to the performance, its performance is 20 million instructions per second at a speed of 20 MHz. And we have a flash memory of 32 KB and SRAM, that is a static random access memory of 2 KB, and electrically erasable programmable ROM of 1 KB. It has 28 package pin count, and some other microcontrollers in this series also have 32 pins. Next, it has 16 capacitive touch sensitive channels and 23 input output pins and 2 external interrupts, and it has no USB interface. We should externally connect the USB port in this Atmega 328. That is, we use it to connect the USB port externally in Arduino board, because Atmega does not have access to USB port. Next, that's all for microcontroller. Next, coming to the Internet of Things, IoT. The term IoT or Internet of Things refers to the collective network of devices and technologies that facilitate the communication between devices and the cloud, as well as between the devices themselves. The Internet of Things integrates everyday things with the internet. An IoT ecosystem consists of web-enabled smart devices that uses embedded systems such as processors, sensors, and communication hardware to collect and send and activate data they acquire from their environment. And next, the IoT devices shares the sensor data that collect by connecting to an IoT gateway or other edge devices, where data is either sent to the cloud or to be analyzed or analyzed locally. Here what we have to discuss is, many things and devices are connected to the internet. It may be at home, or it may be at a factory, or it may be in any industry, and many. The IoT has many applications in space, satellite industry, next rocketries, next manufacturing industries, software industry, and it is also mainly used in home automation. Next, sometimes these devices communicate with other related devices and act on information they get from one another. The device do most of the work without human intervention. Although people can interact with the devices, for instance, to set them up, give them instructions, or access the data. Next, this is the overview of an Internet things. Many devices, services are connected to Internet of Things. Next, coming to the architecture of Internet things, many devices, it may be a low power devices or existing IoT devices, these devices are already connected to IoT. Next, all these are connected to the processing unit through a cloud or a gateway. And next, this processing unit performs many instructions that we want, and a application program is introduced in this processing unit. Next, after particular applications, next the output is of presentation is exposed in many ways. Next, let us see the inflection points of an IoT. Hardware is getting cheaper, and machine-to-machine solutions are mainstream. Connectivity is proliferating. Software is more advanced. Cloud cost, scale, flexibility, all these are main advantages and inflection points of the IoT. Next, coming to the general technical requirements that we want for an IoT is many devices, large scale servers, next security requirements, volume of the data, and end-to-end integration. All these are requirements of an IoT. Coming to the challenges that were faced by the IoT are addressing scale, connectivity, data volume, and device size. All these are main facing challenges for an IoT. Next, to the first principle that we need to learn for an IoT is addressing scale, connectivity, data volume, data size. Next, publish or subscribe for an IoT. Next, cloud, queues, storage, that is cloud storage. Next, AMQP means advanced messaging queuing protocol, or MQ, terminary transport. All these are messaging services that need for an IoT. That's all for IoT, Internet of Things, IoT. Next, coming to the Blink platform. Blink is a platform for the development of smartphone application that work with a wide range of microcontrollers. Blink is a full suite of software required to prototype, develop, and deploy and remotely merge connected electronic devices at any scale for personal IoT project to million of commercial connected products. With Blink, everyone can connect their hardware to the cloud and build a no-code iOS, Android, and web application to analyze real-time and historical data coming for devices, control them remotely from anywhere in the world, receive important notification and such more. Here, Blink connects many things or devices through a server or a cloud. Mainly, the Blink platform is an open source which doesn't cost anyone, and this Blink platform is no code. That means no basic coding is required to perform a function using a Blink. Next, coming to the advantages of Blink platform, no mobile program is needed. That means we need not to learn any programming language to perform a task using Blink platform. It's coming to the concentrate on the functionality. The Blink app mainly concentrate on functionality, and it is on an open source, that is free to everyone. Next, projects are shareable. That means a person one performing a project using the Blink app can also share his project with other friends. Next, this is the main Blink server. This is the main flow of a Blink using for our project. Coming to the the Blink server is connected to Blink app and to the devices. That means that we programmed using a Arduino. This Arduino using internet access or a Wi-Fi is connected to the Blink server. On the other end, the Blink app also connected to the Blink server. That means the devices are connected to Blink app. That means we can control them using Blink app from any end of our world. That is from my turn. All this about Blink platform. Thank you.
Thank you, Mohan. My name is Sheikh Imran. I am studying third year Tribili in VR Siddhartha Engineering College, and I will continue this project presentation. So, in this is the objective of the project. Means our main aim is to control the heater and cooler remotely, and to control the LED during daytime and night time. This is the one of the objective. And next, to control the water tank through the internet, means control the inlet valve and outlet valve through the internet. Finally, after these three objectives, then we will conclude that then it is a home automation system. So, going to next slide, this is the requirements to complete our project. First of all, we have two types of requirements. One is hardware requirement and software requirement. So as a software requirement means, as we have done in simulation, so the software requirements are required. Software requirements is Arduino IDE, Blink app, internet, basic embedded in C language. So we have installed Arduino IDE in the system and Blink app in the mobile phone, and we have internet access and basic embedded in C language. So we write the code in Arduino IDE with C language. So coming to hardware components, first of all our first requirement is Pixim Lab simulator. So this is the Pixim Lab interface. So this is the Arduino board, and then next is LDR is a sensor for garden lights, and this is the LEDs which will assumed as a garden lights in this simulation. And next, this is the CLCD display which will print the messages, and this is LM35. This is used for temperature control system. We will see this requirements uses, and this is the cooler system, and this is Ethernet. Ethernet which connects this purpose is connects the Arduino IDE and mobile phone through the same internet. And this is serial remote tank which will act as a water tank in our project. And then this is the methodology. So our methodology is we will control the home devices with the smartphone using Arduino. So this is our methodology. From Arduino, getting instructions from sensor, light sensor, temperature sensor, stepper motor. So these are all sensors. This gives the information of the physical states. From this information, the Arduino is process the data and perform specific applications, and that application is going to connect with Blink server through the Ethernet. Blink server is nothing but where the information is stored corresponding to our instruction with the same address. So moving on to next slide. This is block diagram. Our first objective is temperature control system. So in this temperature control system, this is the block diagram. This is Blink IoT app, and this is Arduino Uno, and this is CLCD, and this is temperature system. Nothing but in our home this temperature system is there and the CLCD display is there. We control this temperature system and print the message of status of the temperature system in CLCD through using the Blink IoT app. This can be done using Arduino Uno. From the Blink IoT app, we send the instructions to the Arduino Uno. Yet there we will control the temperature system and print the messages in CLCD display. So for that we have to initialize the pins and configure the pins, which pin is connected to which pin. So this is the important thing. While we have done in the project, proper pins to be connected to the proper configurations is needed. So here first Blink IoT app, we have to send the instruction heater control through the V2 pin, and then cooler control through V0 is nothing but instructions means turning on or off in this Blink IoT app. From there it goes to the heater control and cooler control. These instructions is first of all goes to the Arduino Uno and then it goes to the temperature system. In this Arduino Uno process this instruction and send the function through the temperature system. Nothing but to turn on and turn off. This is the specific function. So from there this temperature information is nothing but the status of the temperature system is goes to the again Arduino. From there is another three outlet ways. One is notification and temperature. In CLCD also it displays the status of the temperature system, and notification means temperature control is on, and it displays the temperature how much centigrades is also. And then again outlet is temperature, which displays the temperature in our mobile phone also. And then notification also is sending in our mobile phone. This is all, everything is done in our project. This is all see in the demo video. So this is the block diagram and what we have done in temperature control system, what is the purpose, how to be done, and this is the block diagram. So next is water tank inlet and outlet valve control. This is the another objective of our project. So similar to temperature system, Same is happened here also. One thing is changed, that instead of temperature system we use water tank in this block diagram. So remaining all the process is same, and similar way we have done this also. So next we will see the our project model. This is nothing but in this home layout. In this home layout we have cereal water tank and garden lights, and then we have temperature system in this home layout. And this is my Blink mobile app. Nothing but in my phone I have installed a Blink app. So we have control these home devices with the phone through the Pixim Arduino Uno. This is nothing but in Pixim lab we have using Arduino Uno. Through the Arduino we can control the home devices with the phone. So how it is done, let's see. So from these similar as we see in the previous slides, this is nothing but Blink app. We send the instruction to the Blink cloud server. Blink cloud server is nothing but as we said earlier, which stores the information, and we send the instructions and then go to the Pixim, I mean Arduino Uno board, and here process that instruction and goes to the and send the instructions to the devices in home. Thereby the devices are controlled, sorry. And from this the status of these devices is again go to the Arduino Uno, and Arduino Uno, from Arduino Uno it goes to the Blink server. From the server again it goes to the Blink app, which shows the notification in our mobile app. So this is our project model. We have done all these things in demo video. So let's see the demo video in next slide. So this is the program code for home automation in Arduino IDE. This is the main home automation code file, and this is the LDR C program file. In this file, C programming for LDR, and then move to the serial tank .cpp file for serial tank, and then move in temperature system cpp for temperature system. So go back to the home automation code, and this is the whole code in Arduino IDE to upload the code in Arduino board. So move upward, and there is a sketch. In that, select the sketch and export compile hex code, and it's then run the program. It starts compile code. Wait for a second and then compiling. Now open the Pixim lab. This is okay, this is the Arduino board in Pixim lab simulator. So go to modules and select the spare parts, just a second, and this is the spare parts for our home automation code: CLCD and cooler and Ethernet and LED and LDR sensor. Now go back to the board, go to tools and select the serial tank. This is serial tank for our project. Now go to the files and load hex files in your desktop. Now starts the uploading. Oh, so now it's connect. Once again it is not connected. Once again reload the hex file. So now we have to see that the volume of the gauge is increasing. I want to show my phone. Wait a second, and this is my phone. Here my water volume gauge in my phone is increasing corresponding to the water level, and inlet valve is also enabled, and corresponding to water tank water level. This is the dashboard. It displays the notification. Wait a second. So now its displays water level is full, water outflow is enabled. If you turn on the outlet valve,
press on outlet valve, it starts decreasing, and corresponding to that also is decreasing. Volume gauge is also decreasing up to 2000, because our code is like that, we are written, and it displays water level is 2000, less than water inflow is enabled. Inflow is automatically enabled. See here, inflow is automatically enabled, and turn off. And then if you want to control the cooler, turn on the cooler button, it starts rotate and it displays cooler is on. And then if you want to temperature, heater is on, and temperature gauge is displays the increasing temperature in our phone, and it displays that it's above 35 degrees Celsius, turning off heater. And now if you want to on the cooler, the temperature is decreases, so it is shown in gauge. Now if you want to control the garden light system, so this is the LED, and during daytime the resistance is very less from the sensor, so LED is in off position. During night time the resistance is very high, offered by the LDR, so the voltage is across the.
So that is the demo video. This is the overview, nothing but what we have learnt throughout the internship, Emertex internship. So first of all, we have learnt about home automation using Blink app. Nothing but we have controlled the home devices using Blink app. And then for this control, we required some C language basics, and this is also we have learnt in this internship. And then how to control and operate the device using Arduino, and how to connect the devices, nothing but temperature system, water control system, the devices garden light system, the devices how to connect to the Arduino for controlling with the Blink app. This is also we have learnt in the internship. So thank you, thanks to everyone, and thanks to Emertex.